In the early 80s, the American Space Shuttle flew like a big experimental truck in orbit. It launched satellites, ferried experiments, and came back to a runway landing like an airliner. Beneath the patriotic speeches sat a practical promise. This machine would not only throw hardware into space, it could go back and pick it up again. The Palapa and Westar rescue was the day that promise stopped being a brochure line and became a real, dangerous job for a small crew. The trouble started with two normal communication satellites. Palapa B2 was headed for Indonesia, Westar 6 for commercial customers over North America. Each was about the size of a small car and weighed around 12,000 pounds with its apogee kick motor attached. The shuttle's job was simple on paper. Lift them to low Earth orbit, push them free with a spring, and let a small solid fuel upper stage do the rest. That upper stage was called a payload assist module, a tidy way of saying last shove. On launch day, everything looked fine. The shuttle deployed the satellites, the PAM motors lit on command, bright plumes flashing against the black. Then the exhaust for one of them changed shape, a tight needle of flame puffing out into a dirty cloud. Inside the shuttle, someone watching through the window could see it clearly. Something had snapped. The nozzle had failed mid-burn, and the stage shut down early. Instead of climbing toward 22,000 miles above Earth, the satellites were dumped into a much lower lopsided orbit, looping between roughly 150 and 600 miles. They were moving too fast in the wrong pattern, with nowhere near enough energy to climb the rest of the way. Technically, they were now junk. They could not reach their intended orbits. They could not be easily replaced, and they were insured. Back in London, underwriters at Lloyd's realized they were about to write a painful check. Satellite insurance was still new, but the payout was brutal. Payout for Palapa and Westar together was around $180 million in mid-80s money, the largest space insurance loss to date. The contracts were clear. The policies had to be honored. When the money moved, ownership of the damaged assets shifted. Overnight, a group of quiet English financiers effectively became owners of two very expensive, very misplaced machines orbiting the Earth. What made those people interesting is that they did not simply shrug and call it fate. This case was different. These satellites were not broken. They were stranded. Every major subsystem except the upper stage still worked. Antennas were folded, electronics were fine, propellant tanks were full. If someone could somehow grab them, ferry them back down, and hand them to a manufacturer, they could be refurbished, strapped to another rocket, and sent on their way. That would not erase the loss, but it would claw back millions. To an underwriter, that was worth a bold phone call. On the other side of the Atlantic, NASA was trying to prove that the shuttle was more than a fancy way to toss cargo overboard. Engineers had always imagined it as a service vehicle capable of inspecting, refueling, and even repairing satellites. They had the tools. A robotic arm called Canadarm bolted to the payload bay. A manned maneuvering unit jetpack that let astronauts fly untethered around the shuttle. And a huge open bay big enough to swallow a school bus. What they did not have yet was a mission that tied it all together. When the proposal arrived from the insurance world, it fit almost too well. Pay the agency to rendezvous with two free-floating satellites, capture them, secure them in the bay, and bring them back to Earth. No one pretended this would be routine. Meeting another object in orbit requires precise burns. A small error can mean missing by kilometers or crashing into your target at closing speeds that tear metal apart. The satellites were slowly tumbling, turning roughly once per minute. They had been designed to unfold once and then point quietly at Earth for years, not to be grabbed by a visitor in a jetpack. The tools for that did not yet exist, so engineers in Houston and Colorado got to work designing one. The result looked a little like a medieval weapon and a little like plumbing hardware. Officially, it was the apogee kick motor capture device. Unofficially, astronauts nicknamed it the Stinger. A long boom mounted in front of the MMU, it ended in a narrow probe sized to slip into the throat of the satellite's engine. Inside that probe were mechanical pedals and hooks. The plan was simple on the whiteboard. Fly up behind the satellite, carefully match its spin, ease the stinger into the engine nozzle, pull the trigger to expand the pedals inside the chamber, lock them against the metal, and then use the jetpack to break the rotation and tow the whole assembly back to the shuttle. Before anyone tried this above the planet, they rehearsed obsessively. Neutral buoyancy tanks cannot perfectly simulate zero gravity, but they reveal bad assumptions. In the water, astronauts practiced approaching mock-ups while trainers yanked cables to simulate unexpected spins. Simulations and mission control replayed possible failures: the satellite getting away, a collision with the shuttle, a frozen latch, an MMU low on fuel. Only when they had a procedure and backup moves did NASA assign a real mission. The rescue would fly on the Shuttle Discovery as STS-51A in late 1984. The crew included mission specialists Joseph Allen and Dale Gardner, the men who would ride the jetpack and do the wrestling if it came to that. Another astronaut, Anna Fisher, would operate the Canadarm from inside the cabin. The plan was to chase down Palapa B2 first, then Westar. Ground teams used the satellite's own small thrusters to lower their orbits as much as possible and trim their spin to something predictable. Discovery maneuvered into position with careful burns, trading propellant and time for a closing speed, gentle enough that the targets drifted into view rather than flashed past. When Palapa finally floated outside, it looked huge in the black, a spinning drum against a thin blue earth. Allen strapped into the MMU, the stinger projecting out ahead like a lance. He pushed away from the safety of the payload bay and became, for a few tense minutes, a free-flying vehicle. There was only the hiss of nitrogen nozzles and calm voices on the loop. Matching the rotation was the first test. Too fast and he would overshoot. Too slow, and the satellite would slide away before he could insert the probe. He caught it. The stinger slid into the engine nozzle, the pedals flared, and suddenly 12,000 pounds of hardware were attached to Allen's chest. Technically, the satellite was weightless, but it still had inertia. Every jet of nitrogen moved both of them. He began firing the MMU thrusters, easing the tumble down toward stillness. From the shuttle, the crew watched a man in a white suit slowly tame a spinning metal planet. The next step was supposed to be straightforward. Gardner, waiting in the payload bay, had a capture bar and fixture designed to clamp onto the satellite's body. Once installed, that fixture would give Canadarm a clean, strong place to grab. Then Fisher could swing the whole assembly gently into the bay, where additional restraints waited. But when Gardner tried to fit the clamp, it did not seat. Somewhere in the chain from drawings to hardware, a dimension had been off. With antennas folded, the real satellite was slightly fatter than the model. The bar simply would not latch. That was the moment the mission stopped being a demonstration and became a problem-solving exercise in the purest engineering sense. They could not leave the satellite attached to the stinger forever. Fuel on the MMU was limited. Every extra move cost safety margin. Aborting the capture and leaving Palapa in orbit would waste months of planning, millions of dollars, and a big piece of NASA's credibility. Yet forcing the hardware and damaging either vehicle would be worse. The answer was to change who held the load. Allen returned to the payload bay and anchored his boots into a foot restraint bolted to the structure. Now his body became a human post. Palapa hung above him, attached through the stinger. Fisher used the Canadarm to steady parts of the mass while Gardner worked directly underneath, hands on the new mounting hardware, turning bolts as carefully as a surgeon. From the ground, through grainy cameras, it looked almost mythic. One person holding a satellite, while another fastened its new skeleton. There was nothing magical about the scene. They were using torque wrenches, handholds, and pre-planned steps. But there were variables no one had fully modeled. How the flexible structure would ring when nudged, how close the satellite could safely swing toward the bay walls, how shaky human arms would feel after hours in a rigid suit. A slip big enough to slam metal into the orbiter's tiles could end the mission, and maybe the vehicle. That they pulled it off without incident says less about luck than about all the hours spent before launch, arguing over procedures and worst cases. The next day, they did again with Westar 6, this time with a clamp that fit as intended. Gardner took the MMU slot, flew out to the target, and repeated the capture. Canadarm did more of the heavy lifting on the second try. Practice had shaved the unknowns down. By the time both satellites were tied down in the bay, the shuttle looked like a pickup truck stacked with strange cargo, each drum locked into custom cradles for the ride home. Back on Earth, the satellites were handed over, refurbished, and eventually relaunched on conventional rockets. The insurers did not get all their money back, but they turned a total loss into something survivable. NASA, for its part, had proven the shuttle could act as an orbital tow truck. The images of astronauts riding jetpacks and manhandling satellites became symbols of a brief, wild moment in human spaceflight, a time when improvisation and ambition felt almost unlimited. That moment did not last. In January 1986, the Challenger broke apart shortly after liftoff, killing its crew and shattering the illusion that shuttle flights had become routine. Among the changes that followed was a quieter one. NASA retired the MMU from operational use. Free-flying jetpacks and daring satellite wrestling no longer fit the agency's appetite for risk. Commercial satellites went back to riding expendable rockets instead of hitching rides with crews. The era when an astronaut might fly out and personally grab a failed spacecraft faded into history. What remains from the Palapa and Westar story is a compact lesson in how serious people respond when something expensive and complex goes wrong. They start by accepting the physics. The orbit is wrong, the energy is missing, the cost is real. They look for remaining value. Intact hardware is still worth something if you can handle the logistics. They design a sequence that respects constraints instead of wishing them away. Limited fuel, limited time, limited tolerance for improvisation. Then they rehearse until the extraordinary feels almost dull, because in this business, dull is what you want when metal and human lives share the same thin shell in vacuum. That mindset shows up every time a technician refuses to skip a checklist step just to look fast, or when an engineer insists on one more review of dimensions so the clamp will fit next time without acrobatics. Spaceflight punishes vanity. So does life, just more slowly. The satellite rescue compressed those lessons into a few orbits, plumes of nitrogen from a jetpack, and two big cylinders riding home in the belly of a machine that was always trying to be both a symbol and a tool.
Failure to salvage, refurbishment, we accept the physics. Initially stranded, these satellites eventually reached their operational orbits. The path from red to green served the twin satellite rescue, one of the most complex retrieval missions ever flown. It is the accumulation of these mundane tasks, the tightening of a final bolt, the signing of a checklist, the tying the orbital and financial sides into a single picture of serious people operating with finite margins in different domains. For a brief time, a crewed spacecraft went back, grabbed its own cargo, and proved what was possible.